Welcome everyone to the part 7 of this video series, and in this video we will be discussing about the infinity type questions, that is the questions where the limit of x will be tending to infinity. Now conceptually this video is the last video of the series. There are more videos to come of course, but those videos will be based on mixed concepts, and as far as the concepts are concerned, yes, this video is covering up the last concept that you need to learn in limits. Let's get back to the question. X tends to infinity. Now see, infinity is a never ending number. It is not a real number. So if the value of x is infinity, can the value of x really exist? The point is x tends to infinity means that x is not infinity. X is only approximately equal to infinity. That is, they are trying to tell us that the value of x is a very large number and you can consider it almost as infinity. So just to clear it out, infinity is not a real number, but here the value of x is not infinity, it is approximately infinity, means that the value of x is a very large number. With that understanding, let's evaluate this expression. Now see, you need to understand that if you divide a number like 2 with 5, the value will be 0.4. Say for example I divide 2 with 7, the value will be 0.28, then 5 and something. Okay, then if you divide 2 with 10, this will be 0.2. See, if the denominator increases, the value for that division decreases. So if the denominator value becomes very large, then the value will decrease to a very less number. If the denominator is very large, I can say that the value will be very small, and a small value means it will be approximately equal to 0. So a finite value upon a very large number will approximately be equal to 0, and with that understanding you can evaluate this expression. So you will say this is limit of x tends to infinity. Let's divide the numerator and denominator, both of them, with x cube. So when you do that, the numerator becomes a plus b upon x plus c upon x square plus d upon x cube divided by e plus f upon x plus g upon x square plus h upon x cube. We just said that if the denominator is very large, the value for that particular expression will be very small. X tends to infinity. So the denominator here is very large, and that is why this value will be 0. X square, see, x is already a very large number. X square will be even larger. So c upon x square, a very large value in the denominator, makes even this number as 0. X cube will also be very large because x was a very large number, and that is why d upon x cube will also be 0. Similarly, this and this term will also be 0, and the final value for this expression turns out to be equal to a upon e. Okay, that's how we are going to solve questions based on this particular concept where the limit of x tends to infinity. In the numerator you have a term in x cube. In the denominator we have 3 brackets, each of them containing an x. So we will divide the numerator and denominator with x cube. That will give us limit of x tends to infinity 1 plus 3 upon x square plus 2 upon x cube divided by, it will be x plus 4 upon x into x minus 6 upon x into x minus 3 upon x. See, that is how I have written the x cube in the denominator. So 1x goes with every bracket, and in the first bracket if you split the terms, it will be 1 plus 4 upon x. In the second bracket it will be 1 minus 6 upon x, and in the third bracket it will be 1 minus 3 upon x. X in the denominator, so the value for that term will be 0. So this will be 0, this will be 0. Keep in mind x is a very large number, so x appearing in the denominator or x square or x cube appearing in the denominator will make the value of that particular term 0. 4 upon x will be 0, 6 upon x will be 0, 3 upon x will be 0. So the final value is, in the numerator it is 1 plus 0 plus 0. In the denominator it is 1 plus 0 into 1 minus 0 into 1 minus 0. That's like 1 into 1 into 1. So the denominator is 1. The numerator is also 1. So 1 upon 1, the final value for this expression is equal to 1. Go ahead with the third one. Again, all you need to do is divide the numerator and denominator with x square. So we have 7 plus 5 upon x minus 3 upon x square divided by 8 minus 2 upon x plus 7 upon x square. These terms will be 0 because they have an x and x square in the denominator. So the final answer is 7 plus 0 upon 8 minus 0 plus 0. Okay, this is a minus 0. Anyway, it does not matter. The final answer is 7 upon 8 for this question. Go ahead with the first question of the second main question. You divide the numerator and denominator with x square. So in the numerator it is 7 plus 2 upon x minus 3 upon x square. In the denominator, root over x power 4 plus x plus 2 upon x square. Now you can write that x square as basically root over x power 4. And root a upon root b is like root over a upon b. So you can club the two roots together and you can say that in the denominator what you have is this. Separate the terms. The first term will be 1 plus x upon x power 4 will be 1 upon x cube plus this will be 2 upon x power 4. Put the value of x as infinity. This will become 0, this will become 0, this will become 0 and this will become 0. So the final value is 7 plus 0 minus 0 upon root over 1 plus 0 plus 0. That will be 7 upon root 1 which is equal to 7, and that's the final answer for the first question. You need to rationalize the expression here. So if you rationalize it, you need to multiply it with root over x square plus 4x plus 16 minus root over x square, plus root over x square plus 16, and divide it with the same very expression. So in the numerator there are two terms which are of the type a minus b into a plus b. The expression for it will be equal to a square minus b square, that is x square plus 4x plus 16 minus x square plus 16. In the denominator is root over x square plus 4x plus 16. Basically this term is left in the denominator, so that will be plus root over x square plus 16. So in the numerator, if you expand the two brackets, you have minus x square and minus 16. X square minus x square gets cancelled, 16 and 16 get cancelled. We are left with 4x upon this entire term. Divide the numerator and denominator with x. So 4x upon x becomes equal to simply 4. And when you divide the denominator with x, split the terms. X can be thought of as root over x square. And now you can club root a upon root b as root over a upon b. So that x square can go inside the square root here. Similarly, you can have that x square going inside the root here. Now x square plus 16 upon x square will be 1 plus 16 upon x square. This will be 1 plus 4 upon x plus 16 upon x square. And because x tends to infinity, wherever you have x in the denominator, this and this as well as this term becomes equal to 0. So in the denominator we have 4 upon root 1 plus 0 which is 1 plus root over 1 plus 0 which is again equal to root 1 which is 1. So the final answer is 4 upon 2 which is equal to 2. That's the value of the second question. Moving on with the third one, it's exactly the same, that is you need to rationalize by multiplying with x power 4 plus 4x square plus x square, and the denominator will contain the same term. So in the numerator it is limit of x tends to infinity. The numerator is a minus b into a plus b. So that becomes a square minus b square, which is x power 4 plus 4x square minus x power 4. X power 4 in the numerator gets cancelled. So you have 4x square. The whole thing divided by root over x power 4 plus 4x square plus x square. Divide with x square in the numerator and denominator. So the numerator will have a 4 and the denominator will have x square. So there will be an x square term here plus x square upon x square which will be equal to 1. You can write that x square as root over x power 4 and you can club it with the root that you have in the numerator. So you have root over x power 4 plus 4x square upon x power 4. Separate the terms. The first term will be 1 and the second term will be 4 upon x square. So because x tends to infinity, this term will become equal to 0 and the final answer is 4 upon root over 1 plus 0 which is root 1, that is 1 plus 1. So the final answer is 2. So the final value for the third question will be equal to 2. Go ahead with the first question of the third main question. We need an x square in the denominator of this term as well as this term. So you can divide the numerator and denominator with x power 6. So we will have 3x square plus 4 upon x square into 4x square minus 6 upon x square into 5x square plus 2 upon x square. This is how we are writing x power 6 in the numerator. And in the denominator, after dividing with x power 6, we will have 4 plus 2 upon x square minus 1 upon x power 6. Split the terms here. This will be 3 plus 4 upon x square. This will be 4 minus 6 upon x square. This will be 5 plus 2 upon x square. So 4 upon x square will be 0. This will be 0 and this will be 0. This and this will also be 0. So the final value is 3. 3 plus 0 is 0. Into 4 minus 0 will be 4. 3 plus 0 is 3. So that's 3 into 4. 5 plus 0 will be 5. The whole thing divided by 4 plus 0 minus 0. That is simply 4. So that 4 and 4 get cancelled. 3 into 5, that is 15, is the final value of question number 1. Similarly, let's go ahead with the second question. It's very clear that because we have a power 7 here, the denominator will be divided with x power 7 and so will the numerator be. So will the numerator be divided with x power 7. So in the numerator we will write x power 7 as x cube in the denominator here, x power 4 in the denominator here, 3x plus 2 upon x power 7, the whole power 7 can be written as 3x plus 2 upon x, the whole power 7. So this will be 3 plus 2 upon x. Similarly, you can take this cube common and you can say this is 3x minus 4, the whole power 7. Similarly, this will be 4x plus 3 upon x, the whole power 4. Split them. And finally, you see that the second term becomes equal to 0. The final expression will have the value as 3 power 7. 3 power 3. It was a power 3 here, right? So this will be 3 power 3. So 3 power 3, 4 power 4 upon 3 power 7. 3 power 3 and 3 power 7 get cancelled, giving you 3 power 4. So we can write the final value for this expression as 4 by 3, the whole power 4. Yeah, so that's the final value for the second question. Let's go ahead with the next one. Again, all you need to do is just rationalize this. So we have limit of x tends to infinity. We can multiply it with root over x plus 1 plus root x upon the same very term. So in the numerator it is root x into a minus b into a plus b, and that will be a square minus b square, the whole divided by root over x plus 1 plus root x. X plus 1 minus x, that will be equal to 1. So this is into 1. So whether you write it or no, it's one and the same thing. In the numerator and denominator, you can divide with root x. So in the numerator, you will have 1, the whole thing divided by root x. So that will give you this upon root x, and root x upon root x will be 1. Club the two roots, and inside the root here you have 1 plus 1 upon x. Because x tends to infinity, 1 upon x will be 0. The final value is 1 upon root over 1 plus 0, that is root 1, which is 1, plus 1, which is equal to 2. So we have 1 upon 2 as the final value for this question. Go ahead with the fourth one, and all you need to do is divide the numerator and denominator with x power 50. In the numerator, you can write that x power 50 as x power 20 and x power 30 divided by 2x plus 1 power 50, the whole upon x power 50. So x power 50 and 2x plus 1 power 50 can get combined as one term, and that becomes 2x plus 1 upon x, the whole power 50. Split them, you have 2 plus 1 upon x. The power 20 can also be clubbed together over here. So it will be 2 minus 1 upon x. Similarly, you can club 3x minus 1 upon x the whole power 30. Split the two terms, so 3x upon x will be 3 and minus 1 upon x is what you have. X tends to infinity, so these two terms will be equal to 0 and so will this term be 0. So the final value is, this will be 2 minus 0 power 20, that is 2 power 20 into 3 power 30 divided by 2 power 50. 2 power 20 upon 2 power 50, that will be 2 power 30. So the final value is 3 by 2, the whole power 30, and that's the value for the fourth question. Let's go ahead with the fifth question and the last one in this video. Now here you can't straight away start simplifying because look carefully at the minus sign that you have here. So you need to first rationalize before you proceed with dividing with x or whatever simplification that you've been doing in the previous questions. So rationalize it with root over x square plus 5 plus root over x square minus 3. Same thing in the denominator, and multiply it by, you need to rationalize it with the denominator also. So root over x square plus 3 plus root over x square plus 1. Okay, and the same thing in the denominator. So this will be equal to limit of x tends to infinity. In the numerator it is a minus b into in the numerator it is a minus b into a plus b. So that's going to become x square plus 5, basically a square minus b square. So x square plus 5 minus x square minus 3. In the denominator it will be a minus b into a plus b, that will be x square plus 3 minus x square plus 1 into, in the numerator you are left with this term and denominator you will be left with this term. So root over x square plus 3 plus root over x square plus 1 divided by root over x square plus 5 plus root over x square minus 3. If you expand the bracket here, this will be x square plus 5 minus x square plus 3, x square plus 3 minus x square and minus 1. Now x square and minus x square get cancelled, plus 5 and plus 3 will be plus 8. X square minus x square get cancelled, plus 3 minus 1 will be 2, 8 by 2 will be 4. So we have 4 into this entire bracket as the value for our limit. Now this bracket can be divided with x in the numerator as well as denominator. So you will have the final value or the final expression looking something like this. Limit of x tends to infinity. In the numerator it is x square plus 3 inside the root plus root over x square plus 1 the whole divided by x, and in the denominator it is root over x square plus 5 plus root over x square minus 3 the whole divided by x. Separate that x in the numerator as well as denominator, and you can take that x inside the root as x square. Split the terms again in the roots. So it will be 1 plus 3 upon x square. It will be 1 plus 1 upon x square. It will be 1 plus 5 upon x square and 1 minus 3 upon x square. All the terms where you have x square in the denominator, these will be 0. So in the numerator you have root 1 plus root 1 and that will be equal to 1 plus 1. In the denominator it is again root 1 plus root 1, that is 1 plus 1. That becomes equal to 2 by 2, which is equal to 1, and that becomes the final value for the fifth question. So I am done over here with discussing whatever sums I wanted to discuss in this video. I hope that these questions have been someplace somewhere helpful to you in your preparations. Do check out the other videos in this playlist. Thank you for watching.